So today we're going to be finalizing our discussion of dynamic traffic assignment. So we're going to take a look at the process for actually running DTA, and then also look at how to review the results and then do some model fine-tuning. And then after that, we'll take a look at how we can deactivate DTA once we've kind of reached a stable state in the model. And then we'll also take a look at the process for converting the final dynamic assignment model to static assignment if that's something you would like to do in the future. So this will be the workflow that we're going to cover today. Again, we're going to start with just the process for running the simulation with dynamic assignment. And then we're going to take a look at reviewing those results and then fine-tuning the model. And this is the portion that might be more of an iterative process where you are going to go ahead and look at the results, and maybe you'll notice some paths that you don't want to include, and then you'll need to make some more network adjustments and then rerun the model and review the results again. And then once you've got the model all set up and fine-tuned, you can then start to run the simulation to find convergence. And after a stable state has been reached, that's when you can go ahead and actually deactivate the assignment portion. And then you can run the simulation like you normally would to collect those evaluation measures. So now we're going to just take a look again at some of the parameters we'll need to set up in order to run the simulation with dynamic assignment. So the first thing that we're going to need to do is actually configure some of the simulation parameter settings. And these are all found in the simulation menu if you go to parameters. And that's going to open up this main simulation parameters window here. And the first step here is really to set up both the period and the start time for the simulation. And in this case, we'll need to match these times with the times that have been set up in the OD matrices. And the first thing we're going to look at here is actually setting up that start time here in simulation parameters. This will need to match that very first from time that's set up within the very first OD matrix for dynamic assignment. And then you'll also want to adjust the simulation time period in order to span the length from the very first from time until the last to time that you have. In this case, we just have a single matrix, but if you did have multiple, you just want to make sure that that period is long enough to cover the time for all of the matrices that you want to run. And then next, we'll also need to set up the number of runs. And this will need to be set to a relatively high value, just so that the simulation can again be run multiple times in order to reach convergence. And this number is really going to vary just depending on the network size and the number of paths that end up being generated. And because of this, you'll probably want to set this number at least higher than 25, just so that you can get a good starting set of runs. If you do set this number too low and maybe the simulation finishes but it hasn't reached convergence, you can always set another, start off another set of runs that are going to reference those last created set of cost and path files. And then you can essentially run a new set that kind of picks up where it left off. And then you can keep running that until that convergence is reached. So no worries if you are running this and you don't happen to reach convergence within this number of runs set. You can always restart it and just kind of pick up where it was and then keep going from there until that convergence has been reached. And when you're out running dynamic assignment, you're also going to want to set this random seed increment to 0. And what this is going to do is it's going to force that seed value to remain constant throughout the assignment process. So it's just going to pick up this random seed here, and it's just going to keep using that same one for each of the iterations. And this is going to keep all of the stochastic variables consistent, such as the vehicle arrival patterns in the network and the speed profiles that the vehicles are picking up. And we only will want this to be constant while we're all running that dynamic assignment process until we reach that stable state and reach that convergence. And then the final adjustment in simulation parameter deals with the dynamic assignment volume increment setting. And when you're running DTA, it can be extremely helpful to start off the model with low volumes and then slowly ramp up that volume until 100% is reached. And this is really important just because that first few simulations are going to have a very small path set. So if we assign 100% of the demand from the very start, there may be severe network congestion that occurs just because vehicles can only travel on a handful of paths. So since we're putting all the demand on a small path set, this can lead to high cost values, which might end up being the best paths. So this can just, again, cause a lot of network congestion up front, and then may also kind of inflate some of those cost values on the paths that are in the network. So in order to avoid this, we can really start out with a smaller percentage of the demand and then increase that with each iteration. And this is something we started to talk about last time, but essentially the simulation parameter settings also works with a parameter setting in the dynamic assignment parameters window. So if we go back to the dynamic assignment parameters window here on the left, which again is under traffic dynamic assignment and then parameters, in here is where we have the option to scale the total volume to 10%. So you'll want to make sure that you've got this checked, and then you also have that dynamic assignment volume increment set in simulation parameters. So if we look at this example, in this case, we're going to be starting off with just 10% of the demand in the origin destination matrices. So we're going to start off at the 10% level, and then the demand is going to increase by 10% in each iteration until we reach 100%. And then at that point, all of the remaining iterations will stay at that 100% level. And these are really all of the main parameters you'll need set up in order to run dynamic assignment. So once you have all of these set up in simulation parameters and in the dynamic assignment parameters window, then you'll be all set and you can start running dynamic assignment just like you normally would start running any other model. Okay, so our next step here, we're going to take a look at some of the different ways to review some of the results once we have some of the dynamic assignment runs completed. Some of the dynamic assignment specific results include looking at the origin destination pair results, as well as the list of paths and the corresponding volumes that travel over each of these paths. And then also a way to visualize volumes in the network using an object called flow bundles. And each of these can really help us determine what paths are being generated and also how many vehicles are taking each of these paths. So in order to view any of these origin destination pair results, the first thing we'll need to do is go into the evaluation configuration menu. And in here on the result attributes tab, there's an internal result option here for OD pairs. So you can just make sure you've got that option checked here. And then you can also set the from and the to time and the interval that you'd like to collect those results for. And then once the simulation has been run, you can start taking a look at some of these OD pair results. And all of these are found again under that evaluation menu, this time under the results list section, and then there's an option there for OD pair results. And once you have that selected, it's going to open up this OD pair result list that's shown on the right-hand side. That's going to open up down at the bottom of the network editor. And the OD pair results contain information about the run number as well as the time interval that they're being collected for. And then you'll also see here the origin destination pair. So it's going to be set up where you've got the OD number shown here and then a colon and then the that zone name, and then you'll see the destination zone as well here. And then also within this OD pair result list, we've kind of got two different sections for different aggregated results. So the first part here is just showing the aggregated departure results for any vehicles leaving the origin zone. And then the second part here is showing the aggregated arrival results for vehicles that are reaching the destination zone. And then both of these have similar attributes. So you'll just see that some of them are called, like in this case, we've got travel time departure versus travel time arrival. So you can just see by looking at the name, whether it's for aggregated results based on departure or arrival. And in this case, the results that we have highlighted here are taking a look at the vehicle travel time, which in this case is just the total travel time for the vehicles divided by the number of vehicles for that particular OD pair. And then we also have the delay time, which is calculated as the total delay divided by the number of vehicles. The relative delay, which is the average delay divided by the average travel time. And then we can also see the volume. So this is where we can see the number of vehicles that are departing or arriving. And then finally, we can also see the distance traveled for those vehicles. And this one is weighted by the number of vehicles that are traveling for that particular OD pair. And next, if we move over to some of the paths that are generated as part of dynamic assignment, these are actually all, you can view these all internally within Vissim. So the path list can be found under the traffic menu, under dynamic assignment, and then in here you can select the path option. And what this is going to do is open up a path list, again at the bottom of the network editor. And in here, by default, you'll just see a few attributes. So you can see the distance of the path, as well as the from parking lot and the to parking lot number. And once you have this list open, you can cycle through these. You can just click on them, or you can use the arrow keys to take a look at each of these paths. But whichever one you have highlighted in here will be shown in the network editor, just displayed in yellow. So this is just a good way where you can easily look through the path list. I know that this can get pretty large, especially if you have larger networks. But you can also sort by some of these attributes, like you could sort by distance or by particular parking lot numbers as well, if you just wanted to take a look at a smaller subset of the path. But this is just a good way to see what paths are being created, and if there's any adjustments you would want to make, like if there was maybe a path was taking a particular turn that you'd want to turn off or something like that. This is just a quick way that you can kind of visualize this and then see what fine-tuning you'll need to do for the next set of iterations. And then the paths themselves, they also contain quite a few attributes that you can add. Again, you can do this by just clicking on the wrench icon in the path list, and that's going to allow you to add in all of these attributes so you can take a closer look at more of the details for each of the paths. And in here you can see things, again, the from parking lot and the to parking lot, as well as that path distance. You can also see the financial cost that's associated with those paths, if there's any particular surcharges or anything that have been added on the network side. You can also see the old edge travel time for the path during the last iteration. And again, these are the edges that are going to be built up in the network using that node structure. So this will be for all of the edges between the nodes, as well as the turns within the nodes themselves. So this will be the travel time to travel along those edges. And then also the new edge travel time for the paths that have been created during that current iteration. You'll also see the old path travel time for that previous simulation run, as well as the new average path travel time for the current simulation run. And then finally, we've got a couple of attributes here for the number of vehicles. So we've got the old volume. Again, this will be the number of vehicles on the path during the last iteration. And then you can also see the number of vehicles on the path for the current iteration as well. And if you do have multiple paths between OD pairs, again, this is a really great view that you can use just to determine how many vehicles are taking which type of path. And you can also use this to determine why vehicles might favor one path over the other, whether it be because of the distance of the path itself, or maybe the financial cost, or maybe just due to those travel times. So this is kind of where you can come in and do a little bit of digging if you're looking at the different path options and maybe why vehicles are taking one over the other. This can kind of help you see where some of those calculations are coming from and how those are going to be built up within that path choice option. And then there's another option as well within Vissim that we can use to kind of see and visualize the path assignment. So flow bundles can be placed on different links and connectors to kind of show you where vehicles are coming from and where they're going to. And in this case, you'll see the flow bundles are going to show up by default with these yellow link bars. And in this case, the width of the flow bundle is based on those path volumes. And you can see here the flow bundle itself is really just going to be a line that's kind of placed on a link or connector. This is known as a filter cross section, so you'll hear us mention that as just a cross section, and that's just referring to the location of where that flow bundle is being placed. And again, you can see the width here based on the volume of the path. So you can see for this particular link, we've got all of the vehicles coming here taking that exit ramp. And then from here, you can see where those paths are going. So you can see where those vehicles are going on each of these different paths. So you can see here that our left turn has a bit lower volume than the through and the right. So again, this is just another way that you can visualize and see where the vehicles are coming from and going to for a particular link in the network. And the flow bundles can be added to the network by selecting this flow bundle network object from that toolbar. And then you can either add these either by pressing, by right-clicking and going through the context menu and clicking the Add New Flow Bundle option. Or you can also just press Control and right-click directly on the link itself. And you can place just a single flow bundle cross-section if you want, but you can also keep left-clicking at this point if you did want to place additional cross-sections on other links as well. So if you wanted to see maybe vehicles going on the exit ramp and then all the vehicles making a right turn and then kind of see where they traveled from there, you can place those multiple cross sections if you kind of want to see a more kind of define the visualization a bit more based on multiple links. And then in order to show the flow bundle bars, there are a few different settings just to make sure that you've got set up in order to visualize those. The first is within the flow bundle graphic parameters option. So if you click on the little icon next to the flow bundles, you can open up that graphic parameters options. And then at the very bottom, you can select the option to show flow bundle bars. And there's also some additional, any of the coloring is done right above that. So if you did want to change any of that parameter, you can adjust that in the graphic parameters as well. And then also in order to visualize the flow bundles, you'll also have to make sure that you've got at least one simulation run for dynamic assignment completed in order to have a path file created. So as long as you have at least one iteration done, you'll be able to see those flow bundles. Essentially what the flow bundles are doing are they're taking a look at the volumes that are stored within these path files. You just want to make sure you've got at least one run completed so that you can display that volume. And then finally, for all of the links or connectors where you want to place a flow bundle, you'll just want to make sure that you've got the link evaluation active for those links, and that just has to be turned on. You can, again, get to this setting either by double-clicking on the link and going through the link window, and you can just turn on link evaluation through there. But if you want to do this for multiple links at once, you can do it through the link list, and you can just click the wrench icon to add in that link evaluation active attribute, which you can then turn on for multiple links all at once. And then once those flow bundles are added to the network, again, you'll see here that on their own, they're just going to show up as these yellow cross-section lines. And then the visualization can be done either by selecting that flow bundle in the network editor. And then once you have that kind of selected, the visualization will appear. Or you can also highlight the item in the flow bundle list. So if you have the list open, you can just cycle through these as well, and that will also turn on the visualization for those flow bundles. And then flow bundles also have a few additional attributes within that flow bundle list. So you can choose to have that flow bundle active for all vehicle types. This will be the default setting. However, if you did want this to only be active for certain vehicle classes, you can uncheck this box, and then you can further set the vehicle classes you'd want this to be set for in the box on the right. You can also set the active time intervals for the flow bundle. So if you just wanted to look at the volumes for a particular time interval, you can just press, there'll be a little arrow that you can press here, and you can check off the different time intervals that you don't want to include. And then finally, there's also an option for the cross-section relevance, and this can be set either to at least one or to all. And this is going to be used if you have multiple cross-sections within the network. And here's an example using that. So in this case, we've got a couple of cross-sections that we've got one on this link here, and then we've got another one up here at the top on this link. So in this case, if you have at least one selected, this will show the volume that traveled over at least one of the cross-sections. So this is shown up here in the screenshot up at the top. So in this case, we're going to see volume that traveled over this particular link or volume that traveled over this link. So you can see in this case, we've also got volume for both of these. So this is kind of acts as like an OR condition in this case. On the other hand, the all option, which is shown down here at the bottom, acts more like an AND condition. So in this case, we're going to have any volume that traveled over both this cross-section and this cross-section. So you can see here we've got some of the volume that got reduced from some of these other links since we're using this as the all condition. So we can see here that the volume is showing up for both of those cross-sections. And then in addition to the visualization, you can also see how many vehicles are associated with the flow bundle itself. So if you are looking to see what the exact number is for this particular link, you can go to the link attributes. You can either do this on the link list or in the link quick view if you select that wrench icon. And in here you can go, you can drill down a few levels. So first you'll just look for the link evaluation segments option. And then from here, if you wanted to look for maybe the average volume, you can go to average. And then within that, you can then select flow bundle volume. So it's down a few levels within the link attributes, but once you get down to the average section, this is where you'll start to see some of those flow bundle volumes. So if you've got a couple of options for the flow bundles, you'll see that they're listed here with the flow bundle number and then the name. And you can just select each of those and you can get those added over here into the column section on the right-hand side. And then once you've got those added, again, those will show up down here if you're adding it in the quick view window, or if you're adding it in the list. The flow bundle option will show up here, and then you'll just need to click on that particular link in order to see that volume information. And you'll notice here that you will need to click on the link itself that does have that cross-section defined in order for that volume to show up. So that way you can see here, in this case, we're looking at the flow bundle for this exit ramp here, and then we've got that volume amount here as well that's showing up. So again, this is the flow bundles are really useful to see the visualization as well as the number of vehicles that are traveling over that particular link. Okay, so now that we've looked at the different dynamic assignment results, from here we can take a look at a few different actions we can take to do some of the model fine-tuning. So while you are reviewing some of those model results, if you do notice a section of roadway that's maybe experiencing more traffic than you would expect, in this case you can apply a cost surcharge to the links or the connectors. And essentially this will just increase that financial cost and deter vehicles from using that particular link. And then on the other hand, if you notice any paths that you would want to remove, maybe if you see vehicles that are making a U-turn or taking a particular ramp sequence that you don't want to occur, you can either apply a route closure, which will prevent vehicles from taking a specific link sequence, or you can also turn off the edges and the turns for the nodes if you completely want to restrict a vehicle from making a particular movement. So for the surcharges, these can either be applied in the link window if you open that up either for links or connectors. And then in here, you'll see there's a dynamic assignment tab. And then here's where you can apply those surcharge values, either for surcharge 1 or 2. You can also do this in the link list as well. If you add in those attributes, you'll find that there's 2 attributes, again, one for surcharge 1 and surcharge 2. And in this case, there are 2 different options, just in case you'd want to keep track of 2 different types of surcharges that are being added in the network. And again, these surcharges are going to act as a financial cost. So you'll see in the path list, there's an option for like a static or a financial cost. And this is where those cost values are going to come from, any of those surcharges that get built up from the sequence of links and connectors that a particular path is traveling on. So again, if you did want to kind of lessen the amount of volume that's traveling over a particular roadway, a good way is to come into the link or connector windows and then just apply a surcharge. And you can kind of start out, this is more of like a fine-tuning process again, where you can set a particular value, rerun the model for a few times, a few iterations, and you can see kind of how that changes the amount of volume that's taking those particular paths. And then if you need to, you can come back in here and fine-tune the value from there. And then again, we can also turn off the edges or turns if you did want to completely restrict a vehicle from taking a particular movement. Again, the turns themselves are within the node, so this is just a particular turning movement, while as the edge closures would actually close the roadways that exist between 2 different nodes. And either of these can be turned off within the nodes list. So if you go ahead and open up that node list, you can then change the child list either to edges for dynamic assignment or for turns for dynamic assignment. And then in this child list on the right-hand side, this is where you can select the closed option if you want to kind of turn off any of these particular turns or edges. And again, this is going to completely restrict this movement. So once you turn these off, there'll be no path that will travel over that particular edge or that turn. And then the final option here is for adding a route closure. And again, the route closure is, instead of closing a particular movement, this is going to kind of close a particular link sequence. And so in here, you can add a route closure by choosing from the vehicle routes option in the network objects toolbar. If you press the little drop down here, you can go down to the closure option. And then you can add the route closures. This is just like any other route that you would normally place, like a static route. So in this case, you can either right click and choose from the context menu to add that new routing decision, or you can also just press Control and right click to place that starting point. So just place the on that routing decision start, and then from here you can just left click to place that endpoint. And then of course you can adjust the route placement from here if you're trying to just prevent vehicles from taking a particular link sequence. And it is important to note that in order for a route closure to work, there must be at least one other option for vehicles to take in order to reach their destination. So if this is really the only way that a vehicle can get from its origin to its destination, then the route closure will not have any effect. So we'll need to make sure that the vehicles do have another path option that they can choose from in order for that route closure to take effect. All right, and then once we've kind of gone through that fine-tuning, reviewing results, and then fine-tuning kind of that iterative process, then we can start running the model in order to reach convergence. So again, convergence is going to occur once we've reached enough iterations and we've run enough of those iterations such that a stable state has been reached, and either the path or the edge travel times or the edge volumes no longer significantly change between those iterations. And again, all of the convergence configuration can be done within that dynamic assignment parameters window. And if you go to the Convergence tab, this is where you can choose those different convergence conditions. And you can pick either one or multiple that you'd want to reach in order to reach the stable state. And then you can further adjust the settings over here on the right. And as we're running the simulation, we can check the convergence in a couple of different ways. There is a raw convergence output file that we can look at to kind of see how the model is doing and kind of check where we are in the convergence process. We can also check the convergence on the paths themselves as well within the path list. And this can be done either within a particular iteration or after you've got maybe a set of iterations completed. So in order to set up that raw convergence output file, first we're going to need to go back to the evaluation menu and then within the configuration section. And in here, since this is a raw output file, this will be stored under the direct output tab. And in here, you can check this write to file option for convergence. In this case, there are no other settings, so as long as you have the write to file checked, you will get this file printed out for each of the iterations that are being run. And this raw output file, you can open this in a text editor, something like Notepad++. And then from here, you can kind of just take a quick glance and kind of see how we're meeting those convergence criteria that we have set up. So these files are kind of broken up into a few different sections. This section here at the top deals with the volume difference information for path and edges. So if you remember back within the convergence criteria settings within the dynamic assignment parameters, there's a couple of different options again for the volume difference. You can either look at volume difference for the edges, and then you can also look at travel time difference. So this top portion of the file deals with that volume difference. And then the bottom half of this file deals with that travel time difference. And again, for both of these cases, within this file, you can see the differences between both the path and the edges. So in either of these sections, the rows that you'll see here are going to represent different time intervals. So you can see here, just depending on how you've got that configuration set up, you can see here that we've got the value for each of the time intervals. And then the columns are going to represent the volume difference range if we're taking a look at that top half, or the travel time difference range if we're looking at the bottom half. So let's take a look at an example here. So in this case, if we're looking at this particular column, we're looking at a volume difference of between 3 and 5 vehicles. So again, these columns just represent a volume. In this case, we're looking at a volume difference. Again, if you're looking at the travel time difference, that would just be a travel time rather than number of vehicles. So in this case, we're looking at, again, a volume difference between 3 and 5 vehicles. And then for this particular row, we're looking at the time interval from 1800 seconds to 2400 simulation seconds. And then if we take a look at the intersection here, we've got the value 13. And so in this case, when we're taking a look at 13 edges that meet this particular condition. So essentially what we have here is that we've got 13 edges that experienced a volume change between 3 and 5 vehicles between this iteration and the last for the 1800 to 2400 simulation seconds. So this file is really mainly used just to see how many changes are being experienced between simulation runs. You can see here that we're not getting a ton of volume differences. You can see that as we increase here, these are much larger ranges that we're seeing, hundreds of vehicle differences. In this case, you can see that we're in the much lower range here where most of our values are falling. So this is really just a good way where you can kind of see if the travel times are changing quite a bit or if the volumes are changing and how much they're changing by. Again, you'll probably see some of these larger changes taking place in those early simulation runs as we're going through the bulk of the volume balancing and the path choice options. And then as you run more iterations, you'll start to see the values kind of fall down into these smaller buckets with these smaller volume differences. So again, this is just a good way, as the simulation is running, you can open up any of these files for any particular iteration and just kind of see where those results are kind of falling. And then there's also a section at the very bottom of this file. So there's just kind of this 2 lines at the very bottom. And this explains more of how the file is doing and how it's matching some of that overall convergence criteria that we have set up. So if you are using the criteria for the travel time along path, then you'll see these first two items here are going to deal with the travel time on path. So here you can see the percentage of paths that have met that overall convergence criteria. And then there's also a weighted option directly to the right. In this case, this is looking at the percentages of paths that have met that criteria, but is weighted by the vehicle volume. And then likewise, if you are using the travel time of edges convergence criteria, here you can see the percentage of edges that met that criteria, as well as a weighted percentage, again, weighted by volume. And then finally, if you are using the volume on edges convergence criteria, we've got a setting here where you can see the percentage of edges that have met that criteria. Since in this case, we're already dealing with the vehicle volume, in this case, we don't have a weighted percentage, but more just the overall percentage. And then at the very end, we also have an option for the assigned convergence. So in this case, we can see whether that simulation run has converged or not. So if we have met that overall convergence criteria, you'll see a plus button show up here. Otherwise, if the overall criteria has not been met yet, you'll see a minus show up here. So again, this section is really most helpful after you've run a large set of those simulation iterations, and you kind of want to see how close the model is to meeting that defined convergence criteria. And then next, we're going to move over to discussing some of those path convergence options that you can view within Vissim itself. So this can be checked either while the simulation is running or after a run has completed. So in this case, you'll want to go ahead and open up that path list again under traffic dynamic assignment. And then in this case, you can add an option here for convergence. And this is going to be checked to see if that path has already met that set convergence criteria and has already reached that steady state. And so this will allow you to quickly filter out those paths. You can sort or filter this convergence attribute here. And then you can just quickly see what paths are still having difficulty converging. And then you can kind of just take a closer look at some of those options. You can also see a bit more detail as to what portion of the path is not converging as well by checking this edge sequence. So if you change that child list dropdown to edge sequence, you can then add in some other attributes here for the travel time convergence and the volume convergence. And this will just show you how those convergence attributes, if those convergence criteria have been met for a particular edge, again, either for the travel time or the volume. So again, this is where you can see if you had a path that wasn't converging, you could look in here to see kind of which particular edge and which part of that path is having difficulty meeting that convergence criteria. And then as the simulation is running, and once that convergence criteria has been met, you will see a pop-up that will display if you have that the default option of ask being set within that dynamic assignment parameters window. So in this case, the pop-up is just going to let you know that all of those convergence conditions have been met. And this will allow you to either stop the simulation as it is. You can also continue running until those conditions are met again. Or you can just continue and complete the remainder of the simulation run and just keep running until that's all completed. So again, this window will pop up if you have that ask setting chosen within the convergence criteria window within dynamic assignment parameters. And then once the convergence has been reached and we kind of have that complete path set, we can then move on from here and go ahead and actually turn off that DTA path set. And then we can make sure that we've reset all of the demand values to 100% for all of the remaining simulation runs so that we can go ahead and collect some of our evaluation measures. So the first step that we're going to need to do in order to deactivate DTA is to open up the dynamic assignment parameters window. Again, in here we can go to the search option, and in this case we're going to turn off the option for search new path. And this will make sure that we have are going to use the current path set that has been created, and we'll kind of lock it down to that particular path set. And then if we move over back to that Files tab, in here we'll just want to make sure we uncheck the option to scale that volume. In this case, since we're deactivating this path search process, we want to make sure that we are going to have 100% of the volume placed on the network right from the start. So we can uncheck that, and then we can also uncheck the options down here to store those costs and store those paths. And once we have those unchecked, then Vissim will not change that last set of path and cost files that we have. So for each of the iterations moving forward, Vissim is still just going to take a look at the kind of stored path and cost files that we have completed. And then from here, we'll also need to make a few more changes back within simulation parameters so we can kind of undo some of those settings that we set up at the beginning. So in this case, we'll want to reset that number of runs back to a more manageable number, something like maybe 10 seeds if you wanted to just collect those simulation results. We'll also want to increase that random seed increment back to 1 in order to turn that stochastic variability back on. Again, this is going to impact things like the vehicle arrival time pattern, as well as the speed profiles those vehicles are picking up. And then finally, we're also going to want to set that dynamic assignment volume increment back to 0%, and this will just make sure that the demand won't change, and it's always going to be at 100% from the start, and keep it at that 100% level. And now that we have dynamic assignment kind of deactivated and we've got our paths and our costs set and locked down, we can then run the simulation as we normally would. So this will run, in this case, another set of 10 runs, just collecting your regular simulation results, and then you can run those all and then perform your analysis from there. And so again, from here, you can just run it like you normally would if you were running static assignment. And then kind of the final option we wanted to talk about today is once you have dynamic assignment completed, there is a built-in option within Vissim if you wanted to convert that dynamic assignment network, which is going to, again, use those OD matrices and the paths, to a static assignment, which is going to use those vehicle inputs and static routes. And by converting to static assignment, this will allow you a bit fewer files to keep track of, so you won't have to worry about those path and the cost files. It'll also allow you to use some other different types of routes. So you could use things like the parking lot routes or partial routes within the network, which currently don't work with dynamic assignment. So once you have this option completed, we also wanted to note that this cannot be undone. So if you do want to do a conversion to static assignment, you'll also probably want to create just a backup version of the dynamic assignment file in case you did want to go back to the dynamic assignment version. So if we take a look at how that's completed, first we'll just need to go to that traffic menu, and then again down to dynamic assignment. And then in here you can select the option to create static routing from assignment. And once you have that selected, it's going to open up this window here on the right-hand side. And in here, the main option up at the top is going to deal with limiting the number of routes that are going to be created as a part of this conversion process. So if you don't want to limit routes and you want to just kind of convert your current path set and convert everything over to static routes, you can just leave this unchecked and then you can click OK from this point on. However, if you do want to limit routes just to simplify the amount of data or remove any unrealistic routes, like if there were things with long detours, or maybe if you had some of those with like very low volume, then you can use this limiting option here to kind of remove some of those routes. There is a small drawback as well with using this limiting option, where if the paths don't meet the criteria that we've got set up here, those paths will be deleted along with their volume. So this limit route option does not move any volume from one path to another, but rather it will remove it if it meets this particular criteria. So if you do have the limit option checked, again, we'll just need to fill out these bottom values, and then we can select OK from here. So in this case, for the limiting of the routes, you can set the relative minimum volume for a particular route. So in this case, if a particular route has a relative volume less than this value, in this case 0.05, that route will be deleted from the file. And in this case, because this is a relative volume, this value must be between 0 and 1. And then there's also an absolute minimum volume value. Again, if the particular route is less than this value here, that route will be deleted. And then finally, you can also set the maximum number of routes that will be created for each path set from an origin parking lot to a destination parking lot. And this will only keep the specified number of paths with the highest total volume, and then it will remove the rest. So if you did have, if you have this set to 10, and if you did have something like 15 or 20 routes, only the 10 will be kept that have the highest volume, and then the rest of those will be removed from the network. So just a few things to keep in mind, again, if you are limiting the number of routes, is that anything that doesn't meet this criteria will be removed along with that particular volume. So then once you have your settings set up, either if you're choosing to limit or to not limit, you can then press OK. And after the conversion process is finished, you'll also just want to make sure that you have dynamic assignment completely turned off. So you'll just want to make sure that you go back into the dynamic assignment parameters window and uncheck the matrices option here. And then in this case, from here, you can run the simulation. In this case, you'll be running, again, the vehicle inputs and the static routing decisions rather than those OD demand matrices and the path. So this really wraps up our discussion on dynamic assignment. I know, again, that was a lot of information to cover. So from here, we can go take a look at our example file. And again, as part of this, we'll also upload both of these example files. We've got one here and kind of an initial kind of starting point. And then we also have a final version as well. In this particular file has reached convergence. So if we take a look at the initial file, again, we've got all of our dynamic assignment objects set up. So we've got our parking lots and our nodes set up. And then we also have our demand matrix set up as well. And in this case, we've got our parameters configured. So we've got, again, our start times are lining up. So we just want to make sure our simulation parameters start time matches that from time for the matrix. And then we also have the period, the simulation time period is also aligning with the length that this matrix is valid for. Also within the simulation parameters, we've increased the number of runs, and then we've also set that random speed increment down to 0, just to remove that stochastic variability when we're running our set of dynamic assignment runs. And then we're also going to do the volume increment as well for that dynamic assignment, again, just so that we can start out with a lower volume and then slowly increase this as we're building up that path set. And in this particular case, we've got our dynamic assignment parameters set up. So we've got our, in this case, we're going to scale the OD demand to 50% for that first run. And then again, for each of the iterations, we're going to increase this by 10% until we've got 100% of the demand reached. And since we are running this from the initial file, we've still got our store, cost, and path turned on. And we've got our path search turned on as well. And we also have some of the convergence criteria set up. And again, we've got that ask option checked, so that way we can see at what particular run that convergence has taken place. And then from here, again, once you've got all of that configured and set up, you can run the simulation. And as soon as we've got the simulation running, again, you'll see the number of runs. In this case, we're running 25. So again, you can always restart this if you ran through 25 runs and found convergence still wasn't reached. You can always restart it with the last set of cost and path files, and then kind of start from there and then keep running until you've got that convergence reached. And again, as you are running this, you'll see that a few files will be placed in your in that file directory. So you'll see some of these cost and path files, so the BEW and the WEG files. And again, these will be printed out for each iteration. So you'll start to see some of these for each of the simulation runs that you've got, which will be used for each of the remaining iterations. And then once you have the simulation run, in this case, our network file is very small. There's not a lot of path options in this case. So this one didn't take too long to reach convergence. I think this was about 13 or 14 runs until we met that convergence criteria. And so then once you have that set, I'll go ahead and move over to this final file. In this case, again, we've got our dynamic assignment parameters. So now that we have dynamic assignment kind of completed, we can turn off those store costs and store paths. We'll also turn off that scale total volume, and we'll also turn off this path search. So that way we've kind of locked down, and we're just going to be using these cost and path files. In this case, I did rename the kind of final cost and path files that we're using. So we're going to be using these for just the remainder of our simulation run. And then for this particular file, we also printed out some of those external convergence files. These are stored with a .dva format. And again, these are what you can open up with a text editor. You can open those up with Notepad. And then you can just kind of see what the some of those convergence criteria look like. So again, you can see how much of the volume is changing for the edges and the path. You can also see how much the travel time is changing. And then you can also see the overall convergence criteria and kind of how that's meeting what we've kind of set up within the file itself. And then as you have these files running, you can also take a look again at those different paths. So I've got this path list opened up. Again, this is just a good way you can just quickly cycle through these just to kind of make sure that all the paths look okay. In this case, again, we've got a pretty small network and we don't have any U-turns or anything allowed. So you can see here we've got a few different paths that maybe we wouldn't want to include. So again, these are things that you could place route closures on if you kind of wanted to prevent some of this from occurring where vehicles are kind of taking these out of the way paths instead of just making this left turn. So this is, again, something that you're going to do as part of that fine-tuning process, just taking a look at some of the paths and taking a look at some of these ODPI results as well, just to kind of see how everything looks. And then from here, again, you can apply those different cost like surcharges. Again, those are on the links and the connectors themselves under that dynamic assignment tab. So you can set some of these. You can also turn off connectors as well for a particular vehicle class. And then you can also set up some of those route closures. So for example, if I go to the vehicle route option and if I change that drop down to closure, this is where you could turn off some of those closure options. You could kind of prevent vehicles from doing some of this kind of behavior. So again, these route closures are really useful for turning off again, a sequence of links. So in this case, we don't want to turn off a particular movement or a particular turn, but in this case, we'd want to kind of limit a particular route, a link sequence from occurring. And so this is where we can use those route closures. We could kick off another set of runs just so that the volumes can be moved from some of those other paths to a new path. You can see in this case, we've kind of wiped out our current path by making some of these edits. But yeah, again, these route closures are very useful for kind of preventing some of these maybe longer routes. Again, there's also parameters within dynamic assignment you can also set up, especially within this choice tab. Like you can choose to avoid long detours. You can also limit number of paths and reject some of these paths. So these can be useful, especially for larger networks, if you kind of want to limit that path choice that's being done for the vehicles. And then again, I guess our last point here, let me see if I can read in our last set of paths here. I'll just reread those back in. And again, if you did want to take these paths that we have created and convert those to a static assignment, again, you can do that under the dynamic assignment menu. And then you can choose that option to create static create that static routing. In this case, you can, again, choose to limit or not to limit those number of paths. And then you can click OK, and it's going to convert all of those. And you should see in this case some of those vehicle inputs created. You will notice that there will be one vehicle input gets created for each parking lot. So there is, you will notice that some of these do get created where those destination parking lots are located. But in those cases, all of the volume will be 0 since we aren't actually generating any volume from this destination parking lot. And then again, from here, you can, you'll also have your static routes that are created. And then you can use this model if you wanted to set up any parking lot routes or use any partial routes or anything like that. Those will work with static assignments, so you can kind of run from there and use any of those options.